Hello everyone. We are given the forward path transfer function of a negative unity feedback system, that is s square plus s plus 1 divided by s cube plus 2s square plus 2s plus k, where k is a positive real number. We are asked to find the value of k for which the system will have poles on the imaginary axis. To know more on the concepts used in solving the problem, kindly refer the NPTEL Control Engineering course, Week 4, Lecture 2 by Professor Ramakrishna Pasumarthy of IIT Madras. We will be using the following concepts to solve the problem. The Routh-Hurwitz table can be used to compute the number of roots of the characteristic polynomial that are on the right half of S-plane and as a result determine the stability of the system. A pole pair on the imaginary axis would give rise to a row of zeros in the Routh-Hurwitz table. We'll now start solving the problem. We are given the forward path transfer function. Let us take it as g of s. So g of s equals s square plus s plus 1 divided by s cube plus 2s square plus 2s plus k. And let us take the feedback path transfer function as h of s equal to 1 since it's unity k. Now first let us compute the characteristic polynomial, so which is 1 plus g of s times h of s equals 0 since it's a negative feedback system. Now we'll substitute these values. We'll get 1 plus s square plus s plus 1 divided by s cube plus 2s square plus 2s plus k times 1 equals 0. Now we'll simplify by taking the LCM, which implies s cube plus 2s square plus 2s plus k plus s square plus s plus 1 equals 0. Now we'll group the like polynomial terms, which is s cube plus 2s square and s square, 3s square plus 2s and s, which is 3s plus k plus 1 equals 0. Now this is the characteristic polynomial of the system. Now let us start constructing the Routh table. S cube, s square, s raised to 1, s raised to 0. So we first fill in the coefficient terms. First term is 1, then comes 3, then comes 3 again, then comes k plus 1. Now we have to find this term. So to obtain that term, we'll multiply 3 times 3 minus 1 times k plus 1 divided by 3. This 3 times 3 minus 1 times k plus 1 divided by 3. On simplifying, we'll get 9 minus 1, which is 8, minus k divided by 3. So you'll get 8 minus k divided by 3 here. There is no term here since there are no further coefficients. Now we'll find this term. So this term will be given by 8 minus k by 3 times k plus 1 minus 3 times 0 divided by this term. So we'll get 8 minus k by 3 times k plus 1 minus 0 divided by 8 minus k. So we'll cancel this to get just the k plus 1 term here. Okay. Now if we look at this row can go to 0 when 8 minus k by 3 equals 0. So which means this row will go to 0 when k equals 8. Now we can see that the poles are indeed on the imaginary axis by checking the auxiliary polynomial. So the auxiliary polynomial here can be found from the previous row. This 3 times s square plus a plus 1 equals 0. Now we'll substitute the value of k, which is 8. This s square plus 9 equals 0. Now we'll simplify this to get s square equals minus 3 and s equals plus or minus j root. This is not asked in the question, but I'm solving it so that you know that the poles are indeed on the imaginary axis. Looking back at the options, we find that the correct option to this problem is option B, k equals to 8. Thank you.